Hello everyone, this is Miss Bernine, and this lecture video is all about X-ray diffraction by crystals, but more on it is all about calculation, alright? So when we talk about X-ray diffraction in terms of the crystals, it refers to the scattering of X-ray by the act of or by the units of crystalline solid. So the scattering or diffraction patterns produced are used to deduce the arrangement of the particles in the solid lattice. So we will be focusing on the calculations related to this. We have here the following problems. Sample problem number 1, X-rays of wavelength 0.154 nanometer strike an aluminum crystal. The X-rays are reflected at an angle of 19.3 degrees. Assuming that n equals 1, you have to calculate the spacing between the planes of aluminum atoms in picometer that is responsible for this angle of reflection. The conversion factor is obtained from 1 nanometer is equals to or equivalent to 1,000 picometer. Now, to solve this problem, we have here the following. We have here again, the distance to calculate that we have equals here, this one. Converting the wavelength to picometers and using the angle of refraction or reflection rather, we write that D equals to the value of the N in lambda. And then we also have here the over 2 sine theta. Okay, so or since n equals 1, you just omit the n here and then proceed to the lambda unit. And then that over 2 sine the degrees theta. All right, so substitution, we will have here the following values. For the lambda symbol refers, again, ito this one here. The lambda symbol refers to the unit that is given, the nanometer that strike the aluminum crystal, the wavelength rather. So that's 0.154 nanometer multiplied 2, since you want to find its picometer value. 1 nanometer is 1,000 picometer, so that you can cancel the nanometer later and you will have PM unit. And then 2 multiplied to sine, then the theta is the degree the degree of the reflected angle, which is 19.3 degrees here. All right, theta is the degrees. And then the next thing you need to do is solve this one, cancel nanometer, cancel, and then perform the operation. You will have the distance of 233 picometer. All right. Second problem, we have here sample problem number 2, X-rays of wavelength 0.321 nanometer strike an aluminum crystal. The rays are reflected at an angle of 17.4 degrees. Assuming that n equals 1, calculate the spacing between the planes of aluminum atoms in picometer that is responsible for this angle of reflection. The conversion factor is obtained from 1 nanometer equals to 1,000 picometer. So this is that. We have here the value of the distance, then we have the lambda, and then the value of the n. The lambda is the unit of the wavelength that strike the aluminum crystal. So omit the n unit, that since that is 1, lambda is equivalent or over to 2 sine the degree theta. So the value of the wavelength that strike is 0.31 nanometer multiplied to the conversion factor of 1 nanometer is equivalent to 1,000 picometer, cancel nanometer, cancel, then over 2 sine, then the degree of the angle reflected, which is 17.4 degrees from the problem. Perform the operation, you will have 536.7 picometer. All right, so that's all. Thank you.